Comparing perimeters and areas of similar figures. Give me a thumbs up if you think all four of those are similar shapes. You think those are similar? Okay. Alright, so if we start with the original, it's got a side of 1, a side of 1, a side of 1. So perimeter, add them all up, right? 1 plus 1 plus 1 is 3. Check. Now area, we're going to simplify area. Area of a triangle, the formula is kind of tricky. Area for a triangle is half the base times height. Do we have the height in that picture? We don't. So we're just going to say one of these little triangles, we're going to call it B. So the area of this is B. What I highly suggest you do in your notes is put a little B right there. This whole thing, we're just going to call it area B. I'm not going to worry about slapping a number on there. Okay, so the next similar figure, we're doubling it. So we're doubling the bottom. The bottom was 1, and now it becomes 2. Because this together is 2. Looks like it's going to be. All right, so that's 2. So what's this side?
2.
Double. What's this side?
2.
All right, so perimeter, add them all up. What's 2 plus 2 plus 2? 6. But then we're going to say there's 4 B's. Do you agree with that? Here's 1 B. So there's another B, another B, another B, another B. Same thing. If you're nervous that you'll get home and you'll forget, feel free to write in this is a B, this is a B, this is a B, this is a B. So just by doubling the sides, the area gets a lot bigger, right? It gets bigger by 4 times. Okay, let's go through the next one. I bet you're already way ahead of me. So the next one, we're going to triple the original figure. So triplet, it was 1 on the bottom. Now this whole thing becomes 3 tripled because 1 plus 1 plus 1 is 3. So this whole side is tripled to a 3. And this whole side is tripled to a 3 because each one of these little guys was a 1. Shout out next now then, what's the perimeter?
12.
12 or 9, what do you think?
9.
3 plus 3 plus 3? I'd say 9. Okay, area, have you written in your B's yet? How many triangles are in there? 9 of our originals. Are you positive? 1, 2, 3, 4,
8,
5, 6, 7, 8. I agree with my 9s. I agree. There's 9 areas. 9 areas of the original triangle. Okay, last one. Try it on your own. I don't want to give it away. Try this one on your own. Okay, raise your hand. How many of you? I have the perimeter. Hands down. How many of you? I have the area. I have a question for you. This triangle compared to the original. Okay, this one we doubled, tripled, because we know the word for this one. Good work. We quadruple it, and we're going to see what happens. Perimeter. Help me, Alex. What'd you get for the perimeter?
I got 12.
12 for the perimeter. Clap twice if you agree. All right. 4 for the whole side. 4 plus 4 plus 4, 12. All right. Help me out with the area then. What did the area become on this one? Emily, what'd you get?
16.
16 of those original triangles? How many got the same thing? Good work, guys. Okay, flip the page. And let's fill in our chart. Okay, what if we have different shapes? So this shape right here, because what shape is this orange one? Totally a square. So if we keep this as our original, the perimeter is 1 plus 1 plus 1 plus 1. Do you agree that it's going to be 4? Yeah? Okay, what if we double the size then? So now it's going to be 2 plus 2 plus 2 plus 2. What's that, guys? 8. What if we triple the sides? So it's no longer 1, it's 3 plus 3 plus 3 plus 3. What's that? 12. What if we quadruple the sides? So now it's 4 by 4 by 4 by 4. What's 4 plus 4 plus 4 plus 4? 16. Huh. Does anybody notice a pattern to that? Can anybody put their pattern to words? Alec, what do you think?
Pretty much times itself by 2 every time.
Times itself by 2 every time?
No, not every time, but first it goes times 2,
Uh-huh.
times 3, and then times 4. So
Oh, I see. So you're talking about the original. So the original one, and then it's times 2, and then it's times 3, and then it's times 4. I totally agree with you. Somebody see another pattern to this? Joy, do you see another one?
I was just going to say it adds the original. sides to itself.
It adds its original side to itself each time. Does that make sense? So here's our original. 4. What's 4 plus 4? Add another original of 4. What's 8 plus 4? Add another original of 4. What's that?
16.
How many of you, I agree with Joey also. That's a great conjecture. So add the original. Anybody have another way to describe this pattern? Okay, can I tell you how my brain saw it? My brain saw it as counting by 4s. Is that true? Start at 4, and then 8, and then 12, and 16. Well, that's pretty much the same thing that Joey said, right? And kind of the same thing that Alex said. It's just however you want to describe it. Okay, so do you think there's going to be a pattern with our triangle? Probably. Let's see if there is one. So this triangle is 1 by 1 by 1. 1 plus 1 plus 1 is 3. But if we double it, it would be 2 plus 2 plus 2, which is 6. If we triple it, what are the sides going to be? Yep, 3 plus 3 plus 3 is going to be 9, for our perimeter at least. And then if we quadruple it, 4 plus 4 plus 4. Okay, can anybody describe that pattern? Can you put that one in words? Go ahead, Jalen. Adding 3. I totally agree with you. Add 3 each time. Anybody else want to try to describe that in words another way? Multiples of 3. Counting by 3s. Okay, our next shape. That dark purple shape. What kind of shape is that, guys? Do you think we're going to have a pattern on this one too? No? Some say affirmative, some say no. Okay, with the rectangle, are all sides equal? No. So we're going to think of this one as 1 and this one as 2. So what's this one? And what's this one over here? Alright, so when we do the perimeter, 1 plus 2 plus 1 plus 2 is... Okay, what I highly suggest on this one is let's draw a little baby version of this, another similar figure, and let's write our dimensions and then add it up. So if we double the sides, what's this one going to be? It was 1, so let's make it 2. So if that's 2, that's 2. Okay, double this one. It was 2, now it's... Okay. So what's 2 plus 4 plus 2 plus 4? 12? Alright, so perimeter is 12 on this one. Okay, let's do another teeny tiny baby version, a similar figure. We got triple it. Triple this side. It was 1, now it would be 3. This one was 2, so it would be 6. Because 2 times 3 is 6. Add them all up. 3 plus 6 plus 3 plus 6. Is it still a pattern? Alright, we'll guess then. What should this one be without drawing it? Yes! They're counting by 1 every single time. 6s. Alright, if you want to draw your picture quadrupling it, you'd have a 4 by 8 and a 4 by 8. Good work. Oh crap. Right here, there should be an 8, right? Thanks, guys. And this would be a 4 right there. Thanks for watching. Okay, this one, I want a hand in the air. Don't shout out. Do you know what shape this one is? Lauren, what do you think? Hand in the air, Donnie? Parallelogram. Guess what? There's a more descriptive version, but it definitely is a parallelogram. I heard it. Was that you, Josh?
Rhombus.
That was Donnie? Rhombus. This is literally, I'm teaching my geometry students crazy things about all these shapes right now. Rhombus, we laugh because we think of a rhombus. Rhombus has equal sides. All sides are equal. What other shape has all equal sides? Square. So we think of a square that got sat on by an elephant, squashed a little bit. So just landed to the side, but it still has equal sides. So do you think the rhombus is going to be very similar to this? It's exactly the same. Okay, so perimeter will be 4 for the original, 8 when you double it, 12 when you triple it, 16 when you quadruple it. It's the same. We have the same sides, so we'll still be adding them up. Okay, so there's perimeter. Area. Now, I don't think that anybody came to the board and did this on the warm-up, but can I show you a real fast way to do area? I bet you already knew. That'll just be a reminder. To find the area, you can just times the sides. What's 1 times 1? 1 times 1? 1. All right, but if we double it, Max, you ready? If we double it, this would become 2 by 2, right? So, guys, what's 2 by 2? 4. Triple it, what's 3 times 3? 9. Quadruple it, 4 times 4? 6. Yeah, see how we can get those really fast? Okay, but now that dang triangle again, right? It's a little bit tricky to find the area of the triangle without using the formula. But we can just think of this as a letter B. Now you are more than welcome to flip back. We already did the triangle, so remember? When we doubled it, do you remember what happened to our picture? How many original triangles did we get by doubling just the side length?
4.
We got 4. So we wrote this as area was 4 letter B's. Okay, but then we go back to our original triangle and we triple the side length. Do you remember how many letter B areas we got? How many?
9.
9.
And it's 16.
And then we talked about how the last one was 16, right?
Oh, that's creepy. Talking about the numbers, that's insane.
Alec, tell me again, what did you notice?
That the square and triangle are exactly the same,
Well, look,
except for the B's.
there's 1 and there's 1 letter B. Do you see that? There's 4, and this one is saying 4 original triangles. This one is saying 9 original triangles. This one's saying 16 original triangles. How many of you can see that pattern? Do you see that? Crazy, right? Okay, let's talk about the rectangle again. So rectangle, to find the area, what's 1 times 2? All right, double it. What's 2 times 4?
8.
All right, thanks, Josh. And then triple it, what's 3 times 6?
18.
All right, good work. And then quadruple it, 4 by 8. Was that you, Donnie? 32?
Yeah.
So area is 32. Good work. Last shape, dark blue shape. Tell me the most descriptive word for that shape. What is it? Okay, it's totally a rhombus. Now, does anybody, I think rhombus is going to be like, from what we talked about. Donnie, what do you think? It's like the square, only tilted. So we put a letter C here. So guys, take what Donnie said, and what do you think is going to go right here?
4.
Yes, good work. That's what area is going to be 4 of our originals.
Next is 9.
Next one is 9 of our originals. And what's the last one?
16C.
16 of our originals. Good work. Okay, do you know how to make a rectangle with your fingers? Alright, so we've got a rectangle with our fingers.
Camera.
Let me tell you a really fast version of a true story. This is true. You can put your rectangles down. Okay, so back in the day, let me give you some background. I have a Grandma Bateman, so my dad's mom. She is crazy, but the good kind of crazy. The kind of crazy where she used to be a cheerleader, and she still acts like a cheerleader. So like happy and bubbly and like for fun all the time. So she got kind of down and out a while ago because she's like, my grandkids never come to visit. So she decided, I'm going to build a pool and that will make them come visit. And we were like, heck yeah, we'll come visit. We love swimming though. So she built this pool. However, she lived out in South Jordan, kind of by Daybreak, if you know where that is, on Complex. But right before then, and she literally, not teasing you, I'm not making this up, she literally lived next to people who had buffalo. Big, ugly, smelly, scary buffalo. So she built this pool, and her neighbors were like, yeah, will you build a fence just in case the buffalo get out and then they won't drown in your pool? And we were like, gross! That'd be so gross if a buffalo drowned in your pool. So my grandma built a fence around the pool. Check. But then the neighbors were like, oh, it's a fantastic fence. However, if the buffalo get out, they'll probably be a little bit crazy. And what if they stampede? Would the fence stand up to stampeding buffalo? No, probably not. So they were like, you need to get a pool cover that a buffalo could stand on. She was like, are you kidding? Those things weigh so much. They would just fall through, right? And rip the pool cover. Turns out they really do make that strong of pool covers. It's more for safety for children in case like a child crawled onto it, they want to break through it, but not so much buffalo. But she really found one, and she really had this awesome, super expensive motorized pool cover that went over and covered it in case the buffalo got out, right? Okay, so there's 2 things in this story. There's the fence and there's the pool cover. We've been talking about area and perimeter. I want a hand in the air. From the story, which one is describing perimeter? Thanks for raising your hand, Tyler. What is it? The fence. So guys, shout it out. Which one is describing area? The pool cover. That's literally what they mean. So why am I telling this? Perimeter, I want you to remember that perimeter is one-dimensional. It's the fence around the pool. Area is 2-dimensional. It's that whole pool cover. It's that whole length of it. Okay, this next part is not in your workbook, so close your workbooks. I know that your brains do better when you write stuff down after you've listened. However, I think you will pick up on this pretty fast, so watch. Back to this problem. Okay, so the majority of today's assignment is going to have you compare the ratios of perimeters and areas, fences to pool covers. It actually can go really quick as long as you pay attention to directions. Right here, they want you to compare red to blue. So you've got to start with the red and then compare to the blue. This builds back, it piggybacks on what we talked about in the first section. So first you want a ratio for the sides, but it has to be red to blue. So start with the red side. 4 compares to. However, it's a ratio. How do you write that? How were we writing before? Ratio is just a fraction. It's a fancy word for it. So ratio of the sides is 4 to 6. Done. Well, in the question it asks for the ratio of the perimeters. Start with your sides. It's 4 to 6. And then here comes the perimeter. It's not too bad. All you do is simplify this ratio. So I want a hand there. How are you going to simplify 4 6s? Amanda, what are you going to do? Yes! She said divide them both by 2. And Amanda, what do you get? Yeah. You're done. That's it. So pay attention to directions so you don't write it backwards. Keep the workbooks close. So that's going to be perimeter 2/3. Now the question doesn't ask for area. However, every single problem on your assignment asks you to do both perimeter and area. So right here, let me show you really quick. Perimeter was 1-dimensional. Area is 2-dimensional. So take the perimeter, take the simplified one. You watching? Chance, you watching? Non, you watching? So 2/3. And all you have to do is square it. Area is always squared. It's 2-dimensional. So 2 squared, 3 squared. However, what I notice students do is they rush through the section because they're like, this is cake. And they do this as 3 times 2. Does that mean 3 times 2? That means 3 times 3. So this is 2 times 2 and 3 times 3. Guys, what is 2 times 2? 3 times 3. That's it. So your 2 answers, perimeter ratio 2/3, area ratio 4/9. How many of you, I've only seen one example, I think I get it. Again, keep those books close, we're going to do more examples. Okay, next. This one, look at your directions. Are we going blue to red or red to blue?
Red to blue.
Okay, red to blue. So first thing, start with your sides. 6/10. Clap twice if you agree. 6/10. Now I want a hand in the air. I've shown you only one example. Can anybody describe how to find the ratio of the perimeter? Go ahead, Charles. What do we do? Divide by 2. Simplify it. 3/5. Give me a thumbs up if we're done with the ratio of the perimeters. We are. You can circle that one. Okay, but let's add to this one. Now we have to find the ratio of the areas. Again, I only showed you one example. Is anybody super confident? I already know how to do it. Can you describe it to us? Do you remember what to do on this part? Okay, Matt, help us out. What do we do? Yes, 3 squared. And 5 squared. Okay, so 3 times 2 is 6, right? And 5 times 2 is 10.
No.
No. Is that going to happen? Don't let it happen. Catch your neighbors. Walk me through. What does squared mean? Matt, keep going with it. What does that mean? 3 times 3. And 5 times 5. Guys, shout out the ratio of the areas. Good work. Okay. Let's do this one and call it good. However, I'm going to have you go red to blue. Okay, so keep in mind, you always just keep it as a fraction, even if it's an improper fraction. Okay, what I want you to do is whisper to a neighbor. Again, you don't have to write them down. Right now, whisper and tell them ratio of the sides. Go. Tell me, what'd you get?
9/6.
Perfect. Okay, whisper with your neighbor. Tell them the ratio of the perimeters. Okay, tell me, what'd you get?
3 seconds.
3 seconds?
3
I want a hand in there. Where did that come from? How did you go from this to that? Divide by 2. No, divide by 3, right? Okay, ready to whisper? Whisper the ratio of the areas. Go. Tell me what you get.
9.
Good work. That's just 3 times 3 on top. 2 times 2 on bottom, which is How many of you? I got it. Okay, two things. Open up your workbooks to both page 110 and 114.